Section 5.5, performing function operations. Our objective for this lesson is we're going to add, subtract, multiply, and divide functions. Okay. So first we need to talk a little bit about notation. Okay, so we're going back to adding, subtracting, multiplying, and dividing. Okay, which might be, well, pretty straightforward, but we're going to be doing it of functions. So we kind of need to talk about the function notation. Okay, so if I had to function here, let's go f of x equals 5 plus 5x, f of x equals 5x, so there's my f function. The name of this guy is f, and then I have my g function, g of x equals x plus 2. I'm going to try color coding things to help make these notes go a little smoother. Okay, so if I have two functions, a function f, which is a function of x, meaning there's x's in it. I put my input as x. And then I have a g function, which is also a function of x, which I, again, put x's in it. So if this is written in parentheses here, f, we would read this as f plus g of f of x. We'd read this as f plus g of x. Really what this means is I'm going to take my f of x function, and add my g of x function. Okay, so I'm going to take my f of x function and add to it my g of x function. So we start my f of x function. My f of x function here is 5x, so we'll take our 5x. We're going to add to that my g of x function, which is x plus 2. Okay. So then now I can take now we just add these two functions. We can add like terms, okay, if we can simplify that way. So my 5x and my x, I can add those and I get 6x plus the 2. So this is my new f plus g of x function. So this in itself is a new function. So this is my f plus g of x function. Okay, so now I have a new function that was my f plus g of x function, which is 6x plus 2. Okay. All right, so now if I'm subtracting these two functions, so this means I want to take f minus g of x. Okay, so I'm going to take my f of x function, subtract my g of x function. Okay. So again, my f of x function is 5x. And we're subtracting the g of x function, but I want to subtract this whole g of x function, so it's very important that we're careful. We put parentheses around it because I don't want to subtract just the first term. I want to subtract the whole thing. Okay, so then now again, we distribute, put together like terms, any of that stuff that we can do, so I can actually distribute this negative through minus x minus 2. Put together like terms, so f minus g of x equals 4x minus 2. Okay, so then now I know, so now I have a way of subtracting the two functions. I can use this just new function here. Okay, multiplication. Okay, so this is f times, if there's nothing in between the f and the g, it's a multiply. So this is me taking my f of x, multiplying it times g of x. Okay, so now we take my f of x function, which is 5x, and we're going to multiply it times my g of x function, which is x plus 2. Again, we don't just want to multiply those first two things, we want to multiply it times the whole thing. So we need to put parentheses around that x plus 2, so we know we're multiplying it by that whole thing. So I now have 5x times x plus 2, so I can't actually distribute here. So I'd have what? 5x squared plus 10x if I distribute into both of those. So that is my f times g of x function. Okay. Last is our division function. So this is me taking my f of x function and dividing it by my g of x function. Okay. So then my f of x function is 5x, and we're going to divide that by my g of x function, which is x plus 2. We look to simplify if we can. I don't think this x is within an addition, so I cannot simplify there. So it looks as if that's as far as it can go. So f divided by g of x is equal to 5x divided by x plus 2. All right, one thing to keep in mind always in functions is their domains. Again, domain, remember, is their input, okay, or your x values. What can you put in to this function, okay? For the most part, our domains have a lot of times been all real numbers. Really, there's only two cases where you need to be careful, okay? So for our domains, you need to be careful in two different cases. One is if you're dividing, because you can't divide by 0. So whenever I have a division, okay, we have to be careful because in my division here, my fraction, if I have numerator and denominator, this denominator guy cannot be 0. So we always have to look to see, is there anything that could make that 0? So that leaves us with some issues for this division. Okay, so I have to be careful on that division, okay? And we're going to talk about domain in these first examples here in a minute. And one other thing we have to be careful on is square roots with an even index. Okay. If my index is even, then whatever's inside of here has to be positive. Okay. So we have to keep that in consideration as well. Okay. But for the most part, unless we have a division with an x in it or a radical with an x in it, we really don't have to worry too much about the domains. It'll normally always be all real numbers. But you have to be careful because the original function could have a domain of all real numbers, but you have to be looking at the process. So here in these original functions, the domain of f of x is just 5x. I don't have a fraction, I don't have a radical, so the domain here is all real numbers. So then here, x plus 2, again, I don't have a division by x, I don't have a radical. The domain there is also all real numbers. Hey, but then we have to look when I add them. Okay, again, does it introduce a division or a radical? Nope, so the domain there is all real numbers. What about when I subtract them? No division by x, no radical. Okay, when I multiply them, no. But look about here when I divide them. Okay, I've now introduced a divide by x. So I now have to be careful because this guy, this bottom denominator here cannot be 0. So I need to look for what makes x plus 2 equal to 0. Well, when we subtract the 2 from both sides, x of negative 2 will make this 0. So my domain here would be all real numbers except negative 2. I can put any number I want to into this function here except for negative 2. Okay? So you really have to be cautious on that division one. Okay. All right, here example 1. Okay. It says let f of x equal 3 the square root of x and g of x equal negative 10 the square root of x. Find f plus g of x and state the domain. Then evaluate the sum when x equals 4. So first we want to find f plus g of x. So again, so now we're going to take my two functions. Here's my f function right there. And then my g functions right here. So now we're going to add them. We'll take f, so this means I'm going to take f of x and add g of x. Okay. Well, f of x is 3 square root x. G of x is negative 10 square root x. So when we add those, they're like terms, they're both root x's, so I can add them. 3 root x's plus a negative 10 root x's gives me negative 7 root x's. So there is f plus g of x is right there. State the domain. Okay, so the domain. Am I dividing by something with an x, or do I have a radical? Well, I have a radical. Does it have an even index? Yes, it does. It's square root. So that tells me that whatever's inside of my radicand, whatever's inside of this radicand, has to be positive. So my x is in there, so my x, my way of stating this, my x has to be positive. I could write it in words this way, or we could shortcut it and write it this way. X has to be greater than or equal to 0. This is the shortest way of writing the domain. You could write it in words if this confuses you. Okay. Then evaluate the sum when x equals 4. So now they want us to plug in an x equals 4. So I want to evaluate f plus g when x is 4. So f plus g of 4. Well, my f plus g of x is now this guy. So negative 7 square root of 4, negative 7 times 2, which is negative 14. So f plus g of 4 is negative 14. Okay, now on to example 2. Okay. Let f of x equal this function right here, and g of x equal this function right here, x to the third minus blah, blah, blah. Find f minus g of x and state the domain. Then evaluate the difference when x equals negative 2. So this is a difference since it's subtraction. So I want to take f minus g of x. So that means I want to take f of x and subtract g of x. Well, f of x is this blue function here, 3x to the third minus 2x squared plus 5. And we want to subtract x to the third minus 3x squared plus 4x minus 2. But I don't want to just subtract the first term, I want to subtract the whole thing. So I'm putting that whole thing in parentheses. So now I can simplify. I'm going to distribute this negative through. Minus x to the third, this will give me plus 3x squared minus 4x plus 2. Now put together like terms. Here we have 3x to the third minus x to the third, 2x to the third, negative 2x squared plus 3x squared plus x squared, so we got that back, minus 4x minus 5 plus 2 plus 7. So this is my f minus g of x function. Okay, right there, my f minus g of x, that guy right there. Now it says, then state the domain. Well, look at my original functions. Do I have any divide by x or square root with an even index? Nope. What about that guy? No. What about my final product? Nope. So my domain is then all real numbers. Okay. Now it says, and then evaluate the difference when x equals negative 2. So I now want to evaluate f minus g of negative 2. So 2 times negative 2 to the third plus negative 2 squared minus 4 times negative 2 plus 7. Negative 2 to the third is negative 8, so I have 2 times negative 8. Negative 2 to the second is 4. Negative 4 times negative 2 is positive 8 plus 7. Okay, 2 times negative 8, so we've got here 2 times, go ahead and use our calculator to evaluate the rest of this, 2 times negative 8 plus 4 plus 8 plus 7. We get 3. So this equals 3. Okay. All right. Example 3. Okay. Let f of x equal, so there's my f of x, x to the second. G of x equals square root of x. Find f times g of x, because there's the times in between there, and state the domain. Then evaluate the function. So we want to find f times g of x. Well, that's the same as taking f of x, multiplying it times g of x. So my f of x is x to the second, times my g of x is the square root of x. So now we're going to multiply those two. So let's see, putting together, I would just have x squared times the square root of x. But these both have x's in them, and I can rewrite the square root of x times x to the 1/2. They're the same bases, so I can add the exponents. 2 plus 1/2 is 5/2, so this would be x to the 5/2. So f times g of x equals x to the 5/2. Okay. But back in our original problem, which this also, or we could also write it as the square root of x to the 5th. Okay, so this to me looks simpler, so I'm going to leave it this way. But we always have to keep that in mind that that still is a square root of x, which comes in now when we're talking about the domain, when stating the domain. The domain of x squared here is all real numbers because there is no divide by x, no square root. But here, it's got the square root, so this x here has to be positive. X must be positive. Okay. So if x must be positive to start with, if I'm multiplying the two here, my final result, x must still be positive. So x, my domain, is x has to be positive, which the easiest way of writing that is x is greater than or equal to 0. Now it says evaluate the product when x equals 9. So we're going to go f times g of x, of 9. Sorry, we're putting a 9 in. Equals, I'm going to come back and use the square root of 9 and put the 5th on the outside because the square root of 9 is 3. So now I just need to evaluate 3 to the 5th is 243. I could also just take 9 to the 5 halves, and we get 243. Okay. All right, example 4. Okay, let f of x equal 6x, g of x equal x to the 3/4. Find f divided by g of x, state the domain, f divided by g of x. So that means I want to take f of x and divide it by g of x. F of x is 6x divided by g of x, which is x to the 3/4. Okay. Well, this is x to the 1st, and since it's a multiply, I can simplify those two. I'd subtract the 1 minus the 3/4, so my new f divided by g of x would be 6x to the 1/4. Or this would be 6 the 4th root of x. Okay, and state the domain. Okay. Well, the domain on this one is I do have an even index, so that tells me whatever's in here has to be positive. But since it is a division one, at some point here I divided by x to the 3/4. So I had this division here. I was dividing at this point, which tells me then that this thing cannot be 0. X to the 3/4 cannot be 0. Well, the only way that can be 0 is if x is 0. So x has to be positive, but not 0. Okay, because I wouldn't be able to put a 0 into there. So my domain here, instead of saying greater than or equal to 0, x just has to be greater than 0 for the domain here. Okay. And then it wants you to evaluate this quotient when x equals 16. So f divided by g of 16 would be 6 times 16 to the 1/4. So 6 times 16 to the 1/4 is 12. Okay. All right. Okay, now I'm going to actually show you how to do these in our calculator. Okay, one thing your calculator can't do is it can't actually give you this f divided by g of x function. It can't give you this function. It wouldn't be able to give you this one. That you'll have to do on your own. But what it can do is it can give you this 12, if you know the two functions to start with. Okay, so it can give you what you'd get out when you put a number in. Okay, so I'm going to walk you through the steps on how to do that. So they said let f of x equal here square root of x. Let g of x equal the square root of 9 minus x squared. Use a graphing calculator to evaluate f plus g of x, f minus g of x, f times g of x, and f divided by g of x when x equals 2. So you really need to know what your input is. You need to have, just to be able to do it in your calculator, here you need an input value. Okay. If you don't have an input value, you can't really do this in your calculator. So you need that input value. So what we're going to do is I'm going to put these two functions in my y1 and my y2. So I'm going to label here in my work, I'm going to write down, I'm putting this one in y1, I'm putting this one in y2. So f of x is going to be y1. So I go to my y1, want the square root of x. So there's my y1. Now on my y2, I'm going to do the square root of 9 minus x squared. So there's my y2. Okay. So now that I have them in my y1 and y2, I'm going to go back to my home screen, second mode, or this quit button. Okay. And I want to take these two functions, I want to add them, get x. So if I do f plus g of 2, so we're doing f plus g of 2. Okay, what I'm going to do in my calculator is I'm going to take y1 of 2 and add y2 of 2, meaning I'm taking f of 2 and adding g of 2. But f is y1, g is y2. So I can actually get this by going to vars, yvars, function, y1, and then now in parentheses putting a 2 behind it. So that's y1 of 2. Okay, and I want to add to that y2 of 2. So vars, yvars, function, now arrow down to get y2 of 2. So I want to take the first function, my y1, my f function of 2, and add my second function of 2. Hit enter and it'll actually give you that answer. Again, approximately, this isn't exact. It says round your answers to 2 decimal places. So my answer for f plus g of 2 would be approximately 3.65. Okay. So now I can do that and subtract them. F minus g of 2. Well, since I'm putting the same input in, I can just second enter, bring back my previous problem, but now instead of adding the 2, I want to subtract them. So switch that to a subtraction sign, hit enter. Negative 0.82. So that would be approximately negative 0.82. Okay. Now we want to multiply the 2. So f times g of 2. So now I come back, second enter again. I change my subtraction to a multiply. 3.16 approximately. I keep putting equals. Make sure you use an approximately symbol. It denotes to the reader that this is not the exact answer. We rounded. And then last, f divided by g of 2. So again, second enter, we want to take f divided by g of 2, approximately 0.63. All right, so there you can see your calculator can help you find these, but again, you need an individual input value to use your calculator in that way. Okay. It won't work if you're just trying to find f plus g of x. Okay, you need a number. Okay. All right, here's example 6. Okay, here's the last example. For a white rhino, the heart rate R in beats per minute and lifespan S in minutes are related to the body mass M in kilograms by the functions. R of M equals 241 M to the negative 0.25. So this R is the heart rate. So this will tell me the heart rate of a rhino given its mass. So this is, and I'm going to write that down. So here, if I input mass in kilograms of the rhino, it will give me out the heart rate. That's what this function does. I put in M, which is the mass, and my output is the R, which is the heart rate. If I input the mass, it gives me out the heart rate. Okay. Here, this is S of M by this function. Again, here, if I input the mass, how heavy this rhino is, it will give me out its lifespan. Okay. So if I input the mass, how heavy it is, it will give me out its lifespan. How long is it going to live in minutes? Okay. So we want to find R times S of M. So this is R times S of M. Okay. So I would R times S of M. So this means I want to take R of M and multiply it times S of M. R of M is this guy here, so we have 241 M to the negative 0.25 times S of M, which is 6 times 10 to the 6th M to the 0.2. Okay. This is all multiply. So this is 241 times M times that times. So I'm going to multiply the two numbers first. I'm going to multiply the 241 and the 6 times 10 to the 6th. Okay. So 240, I'm going to take 241 times 6. 241 times 6 is 1,446, but that's still times 10 to the 6th. Okay. And then now let's multiply the M parts, because everything's multiply. They're the same base. They're both M's, so I'd add the exponent. So I'm going to take the negative 0.25, add the 0.2. We get negative 0.5, so we'd have M to the negative 0.5. Okay. Now this is in scientific notation, so we should probably keep it in scientific notation. It's 10 to the 6th so far, but this number's too big. It needs to be a number in between 1 and 10. So my decimal right now is here, so I'm going to move it back 1, 2, 3 places. So R times S of M would be, it would be 446 times, and this would be now 10 to the 3rd. It was 6, but I went 3 more places, so that would be 6 plus 3, 10 to the 9th, times M to the negative 0.5. Okay. So there is my final function. There's my R times S of M. Okay, so there's my function. Now it says explain what R times S of M represents. Okay, so let's go back to up here. We talked about R of M. If I input the mass, it gives me the heart rate. Here, if I input the mass, it gives me the lifespan. So really, regardless I'm inputting mass, I'm still inputting the mass. But what I'm getting out is the heart rate times lifespan. So heart rate times lifespan. Okay, so it gives me the heart rate times their lifespan. Well, if I take the heart rate, how many beats per minute, so this would be how many beats per minute, okay, is the, how many beats per minute, and it says up here, beats per minute, is that heart beating, times the lifespan, how long are you going to live in minutes, the number of minutes you're living. If you notice here, beats per minute times minutes, science, your minutes cancel, and we're just left with heartbeats. And this is minutes per lifetime. So this tells me how many heartbeats in a lifetime if I know a rhino's mass. Meaning if I know how heavy it is, how many times is the heart going to beat in its lifetime? Okay. So basically this tells me if I input mass, it will tell me the heartbeats in a lifetime. Okay, so we kind of have that. Explain what R times S of M represents. Okay, it's a function that if you input mass, so if we want to explain it better in words, oh, sorry for the jiggling. Okay, if you know the mass of the rhino, you can find out how many heartbeats it will have, how many heartbeats in a lifetime, in its lifetime. Okay. So if you know the mass of the rhino, you can find out how many heartbeats in its lifetime. Okay. All right. Okay, sorry for the slightly longer video. Write down your practice. Please make sure you're doing your practice appropriately, writing the problem down, showing appropriate work neatly so someone else can follow it. Okay, and good luck.